Bismillahirrahmanirrahim. Dear students, I am Ghulam Mustafa teaching you the chemistry for 5th semester course. Let's see what the curriculum of 5th semester is. Various branches: inorganic, organic, physical, analytical or bio. Today the topic of our discussion is organic chemistry, in which the subtopic is stereochemistry. Before we start the topic of stereochemistry, let's see what the isomerism means. Isomerism is a phenomena in which two chemical compounds having the same molecular formula differ in their structure. That is, they have the same composition but their structure is different from each other. As you see in the flow chart, the isomerism is classified into two major classes. One of them is the structural isomerism and second one is the stereoisomerism. Now, what is the difference between the structural and stereoisomerism? We will see this in a little detail in coming time. Let's concentrate what the structural isomerism is. The structural isomerism is a phenomena in which the isomers differ in the connectivity of their atoms in the different molecular compounds. For example, in the given example, 1-propanol, 2-propanol and ethyl-methyl ether, you can see that the sequence of atoms in all three cases is different. This is also viewable in the 3D structural formula of the compounds shown in the down window of each of the compound. In the first example, carbon number 1 is linked with the functional group hydroxyl group having 2 hydrogen atoms with a methyl group at other position, and there is a methyl group at the end of the compound. Same is the sequence in 2-propanol. Instead that the hydroxyl here in this compound is at position number 1 and in this the hydroxyl position is at carbon number 2. So connectivity is different. Here carbon number 1 bears the functional group and in this case the functional group is at carbon number 2. While in the third picture you can see that the functional group from the previous two pictures is totally different. In this example there is no hydroxyl group but an oxygen is sandwiched between the two carbon atoms. This functional group is called the ether functional group. So it is clear from the picture and from the 3D structure of each of the molecules shown in the diagram that the connectivity of atoms is different in all three cases. Although all these have the same composition, for that is they have 3 carbon atoms, 8 hydrogen atoms and 1 oxygen atoms. Here in this case there is also 1 oxygen, 3 carbon and 8 hydrogen atoms in all three cases. So they have the same molecular formula or composition but their structure is different. So they are isomers of each other. as they are different in the structure, so they are called the structural isomers, and the phenomena is structural isomerism. The second type of the isomerism is the stereoisomerism. In the stereoisomerism, the sequence or connectivity of the atoms is same, but their arrangement in space is different. The atoms lie at different angles, giving a different structure to the compound. For example, here I have shown you the example of 2-butene, in which there are 4 carbon atoms. At carbon number 1, there are 3 hydrogen atoms, quite visible in the 3D model. At carbon number 2, there is a single hydrogen atom, and carbon number 3 also has a single hydrogen atom, and at carbon number 4, there are 3 hydrogen atoms. In both the cases, the sequence of the atom is same. Here also, the first carbon atom has 3 hydrogen, second one has the single hydrogen atom as well as the third one, and the fourth carbon atom has 3 hydrogen atoms, which is also very clearly visible in 3D model as well as in the 2D model of the structure. But you see that in this case, both the methyl group lie at one plane to each other, but in this structure, the methyl group, both of the methyl group are at opposite sides to each other. Such type very clearly visible in the 3D model. If you rotate it downward, it also brings both of the methyl group at same adjacent to each other. Even if you rotate it to right or to left side, both of the methyl group are at same angles to each other, and in this case they are transposition to each other. That is, one of the methyl group is at above and second one is the at downward position. Remember that here the middle carbon atoms have 2 bonds, that is, they have a double bond between them in both of the cases. Now you can see that both of the methyl group are at one plane, so the electrostatic forces generated by different atoms are different from this structure, in which the methyl groups are at opposite sides. The structure of the both is quite and totally different from each other. In this structure, which is named as trans-2-butene, the structure is like a chair, while in cis-2-butene, the structure is like a boat. So they may expect to have different physical characters, and sometimes their chemical characters could also differ, but this depends on case to case. Such isomerism, in which different isomers differ in the arrangement of atoms or in the angles of the atom, although they have the same connectivity, such isomerism is called stereoisomerism. And this is quite different from the structural isomerism. In structural isomerism, in which the isomers differ in the connectivity of atoms. Hope you have understand the topic clearly. We'll meet in our next coming lecture for further topics. Thank you.